Hi Math8 students, here we are today learning about slope at Lith Gilbert Junior High. This is part of our algebra chapter, chapter 9. This is section 4, title slope. These are the vocabulary words that go along with slope, so pause the video, copy down the vocab, and then I'll go through the explanation for each one. Okay, our first word is slope. Typically represented by the m in an equation. This is the ratio of the rise to the run. We write slope as a fraction. Okay, so it's not an ordered pair, it's a fraction. Slope describes the steepness of a line, and we talk about slope when we talk about straight lines. We're talking linear equations. It's the number that represents the steepness of that line. If it's a really high number, that means the line is a really steep line. If it's a low number, the closer it is to 0, the more flat the line is. Okay, we use this Greek symbol. It's a triangle. It's called delta. It means change. Okay, so when we write this fraction over here, we've got the change in y over the change in x. Like I said, we write slope as a fraction. The change in y means how much did the y values change. So we talk about that we talk about that vertical change because the y is the vertical axis. When we talk about the change in x, how much did the x change? We also talk about slope with rate of change. So the words rate of change and slope are used interchangeably. Rise, again, since we're talking about the vertical change, we're talking about how much does the line rise compared to how much it runs. Okay, so we're talking again vertical change, horizontal change. One more way to look at the slope is this equation over here. y2 minus y1 means that for any ordered pairs, we subtract the y values, okay, and then we subtract the x values. And by subtracting those y's, that'll give us that vertical distance, how much the vertical change was, and subtract the x's, that's going to give us our horizontal change because the x's run along that x-axis. So if we subtract those two x values, that'll give us that how much it changed, the difference in those x's. The subscripts on these, the 2 and the 1, they can be changed around as long as you change them for both the y's and the x's. Okay, the order really doesn't matter on those as long as you do them in the same order for both of them. So if you do y1 minus y2, you better do x1 minus x2. You can't switch those around. Okay. The next vocab word is the rise, and like I explained earlier, the rise is the vertical change. This is where you get your y2 minus y1. That's what the rise would be, okay? The change in those y's, the difference of the y's. The run, that's our change in the x's, how much that horizontal distance changes along that x-axis. Okay, so we're looking at that horizontal change. Here is example S. As far as your notes go, we've got these two graphing examples. Take a little piece of graph paper, copy these down, and then we also, I'll just give you a real quick sneak peek here. These are the other 4 examples that will go into your foldable. So if you're wondering how much space to leave for your foldable, we'll have 5 examples altogether. The 2 graphs, and then the 4 examples. Okay, so if you want to pause right here, copy these down onto a piece of grid paper, and then I'll go through the explanation for each one. Okay, on the first one, we're looking for the slope of each line. When you are given a line, you want to find those ordered pairs, find those points on the graph where it meets right on those whole numbers, right on those integers. In this case, we've got a spot right here on the 2, 4. Okay, right here on the 2, 4 is one of those spots where it meets right on the crosshairs. And then right here at 4, 1, we also have a place where it meets on the crosshairs. So I'm just going to copy down these ordered pairs. 2, 4, and then over here we have 4 is our x, 1 is our y. Okay, so we want to find out what is the steepness of that line. What is the slope? So we're just going to follow what is the change in vertical, just making a little dotted line here. So the vertical change, how far did it go down? You can just count the boxes. 1, 2, 3. It goes down 3. So we show that by a negative 3. Okay, so our rise is actually a negative because it goes down. Okay, then if we look at the run, if we look at that vertical distance compared to the horizontal distance, in this case our horizontal distance, okay, we had to go from 2 over to 4, looking at those x's, 2 to 4. So count the boxes. How many boxes is it from 2 to 4? Well, it's a difference of 2 boxes. Okay, so that's our run. Okay, and then slope, we just write it as a fraction. So we write negative 3 over 2. That's our slope. You can put the negative either place. You can either say negative 3 over 2. You could put the negative out front of the fraction. Make that just a little bit darker there. Negative fraction bar. Or you could put the negative in the denominator. It could be 3 over negative 2. All of these slopes mean the same thing. Okay? In the other example, I've got some ordered pairs already on there for you. Again, go ahead and just pick any point on there. I've already put the 3 points where it meets kind of on those little crosshairs. Just count that distance. Typically when we count, we always try to go left to right. So in this case, I'm just going to count up. Okay, it looks like it goes from 3 up to 6. So that's 3 boxes. Okay, you want to count the boxes, not just the lines. And here's my run. My run goes from 1 over there to 5. So when we're just counting those boxes, in this case it goes up 1, 2, 3 boxes, and it goes over 1, 2, 3, 4 boxes. So our slope is 3/4. Notice on the first example, the line, that blue line was going down to the right. Okay, that gives us a negative slope. This second one, this red line was going up to the right. Just like we read a book left to right, we read graphs left to right as well. So in this one, the graph is going up to the right, so that's a positive slope. Okay. Our next set of examples, again, pause the video and then I'll go through an explanation on each of these. So for the first one, example L says to find the slope between these two ordered pairs. So what we're going to do, I'm going to just draw some lines. Just like when we did the distance formula, we're going to do the same thing here with slope. I'm going to connect those y's up on top and the x's down below. Now there's a reason I do that, because the change in y is always on the top. We always talk about the change in y over the change in x. Okay, if you want to use that little formula we had from earlier, y2 minus y1, this is also on your formula sheet, x2 minus x1. So subtract those y's. How far did it go from 4 to 0? From 4 to 0 actually went down. It got smaller. So it was a change of negative 4. From 3 to 2, that went down 1. So if you use the subtraction, you know, like I said, it doesn't matter which ones you use for y1 and y2, or x1 and x2, or x1, y1, whichever subscripts, as long as you keep it consistent and you do the same for both the numerator and the denominator, then you're fine. So our slope between these two is negative 4 over negative 1. Well, if we simplify negative 4 over 1, that just equals a whole number, just 4. So you can either write this as 4 over 1 or just plain 4. Okay, example O, same thing. We're still looking at that slope. If you want to get in the habit of writing those y's up on top, the x's downstairs, because they go down in the numerator. Okay, this time we have a negative value for one of the x's, so we still treat it just like we would a regular number line. So the change in y's, it goes from 3 down to 0, so it went down 3 for the y's. Okay, the x's go from negative 2 to positive 3. Well, if you go from negative 2 to 0, that's a change of 2, and then from 0 to 3, that's another 3. So all the way from negative 2 to positive 3 is a change of 5. This cannot be simplified, so we're just going to leave it as negative 3/5. Again, that's the same as negative 3/5. It's the same as negative 3/5. All three of those are the same. It doesn't matter if you put the negative in the numerator, the denominator, or out front. Okay? Letter P, we're moving along. Find the slope of the line described in the table. So here's a table of values. Now we're looking at kind of like we did a little bit of rate of change before. We're looking at how are these changing. So we've got lots of ordered pairs. You can either pick any, two ordered pairs from the list and do just like we did up here with our change in y's over change in x's if you want to subtract those, or you can find out what's going on in the table. Okay, in this particular table, my arrows could go consistently here. The change from -6 to -2 is going up by 4. So it's a plus 4. From -2 to 2 is also a plus 4. From 2 to 6 is a plus 4. So we have an arithmetic sequence here actually. Okay, so the x's, the change in x is a positive 4. It's going up 4 every time. If we look at the y's, okay, from -2 to -1 means it went up 1. From -1 to 0 means it went up 1. And from 0 to 1, it went up 1. So the change in y was 1. It went up 1 every time. So be careful because this table is like most things. X comes before y. The slope is not that way. The slope is y over x. Change in y over change in x. So we need to just flip these around. So the change in y is 1. The change in x, like we had earlier, is 4. Okay, so our slope, our m value, if you will, equals 1/4. So just like I described earlier in the vocab, slope is a lot of times described by just the letter m. And when we start writing equations, you'll see why we call it m. Okay? Find the rate of change or the slope for the following sequence. So here we've got an arithmetic sequence. Awesome. It's been a couple days since we've done that. Here's our arithmetic sequence. Okay, and we want to find out what is this changing by each time. Okay, if we go back to what we were talking about with, here's our first term, a sub 1, our second term, our third term, our fourth term. Okay, the subscript, that's our x value. Okay, so whenever we use these subscripts down here, we're talking about the x's. Okay, those x's are changing by 1 each time. So the change in x is 1. These terms, these -8, -11, -14, -17, those are our y's. So if we want to know what's the change in y, we start subtracting. So -8 to -11, it's going down 3. Down 3, down 3, down 3, down 3. So if it's going down 3 each time, the change in y is -3. Here's our slope. Change in y over change in x. So even arithmetic sequences have a slope. Notice in these arithmetic sequences, the slope is going to be the same as that common difference. Okay, so when we were writing equations and finding that d value earlier, it's the same thing with these, finding the slope. Okay, hope you enjoyed the video. If you need any questions or have any questions, please ask your teacher. Go back, rewind, go through that vocab again if you need to. Thanks, have a great day.